96. And 96 is where we're going to look at multi-step mole problems and how to write these out. But before we jump into that, I have a summary mole diagram down here at the bottom. So I'm just going to put a little bit of information to help us through. So if we need to calculate a mass or we're given a mass, we will see it tagged with the unit of G. If we need to calculate the mole or we are given the number of moles, the unit symbol is MOL. If we need to determine the volume of a gas that is at STP, or determine the number of moles of that gas, as long as it's a gas and at STP, the volume needs to be in liters. And then lastly, we have the count. And so for the count, we might see a number labeled with particle, molecule, or atom. So those would be the quantity or the units to understand we're starting in a count. So once when we recognize which quantity we're starting with and which quantity we need to get to, we need to think about what's the information. So to convert between mass and moles, that means we need to know the GFM of the substance. If we need to convert between moles and volume of a gas that's at STP, we need to know the molar volume, which is 22.4 liters. And if we need to convert between the count and moles or more moles back to count, we have to use Avogadro's number, which is 6.02 times 10 to the 23rd. And of course, back on our page 88, we have the full mole diagram. We have lots of information on there. So let's take a look here. So map it out. So I see in this question, I see the word determine. So when I see something like determine or how many or calculate, that is what I need to achieve. So it says determine the mass. So that means when I am done with this calculation, the last thing standing mathematically needs to be the mass of the substance, and its unit will be in grams. I need to end up with the number of grams. Now I need to take a look at the information I have to get to the mass. Well, I see this big number, 7.80 times 10 to the 28th power, and I see that it is labeled with the unit of particles. So that means I'm starting off with some sort of count. So the thing that you have to take into consideration is that we are starting here in count. We need to end in mass, but there's no direct link from count to mass. The only thing that I know definitely how to do is to change the count into moles. So from count, I have to go to moles. Once when I'm in my central quantity of moles, now I can go to a variety of places, and from moles I can then make it to mass. So every place where I put an arrow, that means I need one of those equivalence relationships. So when you take a look here, I need two different equivalences. So to go from count to moles, I need to know moles and Avogadro's number. So capital N with a subscript of an A represents Avogadro's number. And then to go from moles to mass, I want to be able to cross off moles, so I put that down below. And the relationship between moles and mass is the GFM. So I'm getting myself set up. Okay, so now to do the full dimensional analysis. Try to write nice and neat. So I have 7.80 times 10 to the 28 particles. And unfortunately, there's no abbreviation for particles. And the type of particles, NaCl. So I already know that in my equivalence is that I want to get to the unit or quantity of moles, and I want to be able to cross off the particle count. So I have that set up. And then I need my next relationship where I'm now in mole and I want to get to grams, and I want to be able to eliminate moles from the calculation. So if you take a look here, I have particle times mole divided by particle. Particle upstairs and a particle downstairs means that particles is mathematically eliminated from the equation. So now I'm at mole times grams divided by moles. I have a mole upstairs in the numerator and a different mole downstairs in the denominator. They are also eliminated. So G for gram is the only unit I have left. So I have a G here. So now that my units work out, now I need to carefully put in the information so I can use the calculator. So here, when it's mole and particle, 1 mole contains 6.02 times 10 to the 23 particles. In the next equivalence, because it's gram and mole, mole to gram, I need GFM. 1 mole, and what I put here, write yourself a little note, is the number of grams that I stick in here. This needs to be the GFM of the substance NaCl. And so the GFM of NaCl would be 23.0 plus the 35.5, which gives me a GFM of 58.5. So for NaCl, there are 58.5 grams of NaCl in each mole. Now it's time to pick up the calculator. So I have 7.80 times 10 to the 28th divided by 6.02 times 10 to the 23rd. I divide because Avogadro's number is below, down in the denominator. And then that quotient, I multiply it by 58.5. Now, because this number here, the number I'm starting with, this has 3 sig figs, my final answer can only contain 3 sig figs. So when you look at your calculator answer, you'll have a big number. But the 3 sig figs that we're going to keep are the 7, the 5, and the 8. And we're going to put it in scientific notation. The coefficient has a decimal between the 7 and the 5. And when you look at your calculator, from where the calculator shows the decimal, to move it between the 7 and the 5, it requires 6 moves. So we have an exponent of 6. So 7.58 times 10 to the 6 grams, and it's grams of NaCl. So there's a lot of writing in here, but this is a complete mathematical sentence, and it mathematically proves how we go from particles of NaCl to the mass of NaCl. Keep your work super neat and organized. Looking at the second problem here. So in this problem, it says calculate the volume. So wherever it says like calculate would be the same thing as determine or how many, and in the end we need to come up with the volume. So that's where we need to end up mathematically, is in the volume, and we're looking for a unit of liters. When we take a look, well, what information do we have to get to volume? We see that there's a number of 86.3 and it's tagged with a G. So that G stands for grams. So we are given a mass. So we are starting off with a mass because the number is tagged with a G for grams, but our job is to get all the way to volume. So our number is tagged with a liters. So take a look here. We're starting off here in mass. We need to get to volume, but there's no direct link between mass and volume. But what I do know how to do is to go from the mass, use information, and to change it into moles. Once when I'm in my quantity of moles, then there is a link from moles to volume. But I need to double check. It says a gas at STP. So when I go and I look at the information in the problem, I see that I have a chemical formula, and the formula is tagged with a G, so that means it is a gas, and the gas is being held at STP. So both criteria are being met to go from moles to volume. So moles to volume, we need to have a gas at STP. And according to our problem, we do have that. So we can work through this problem. So getting my setup, I have my starting quantity of 86.3 grams, and the grams belongs to carbon dioxide, which is in a gas phase. So when you see a chemical formula and little parentheses and a G inside that little parentheses, that's the phase. If you see a number tagged with a G, that means it's a value quantity of grams, the mass. Gets a little confusing. So to go to mass to moles, I need to have a relationship here. So my first relationship is I'm in grams. I need to get to moles, and I want to mathematically eliminate grams. So grams in the numerator, grams in the denominator, and I'm showing mathematically grams can be eliminated, so I'm left with the unit of moles. So I'm right here mathematically now. I got to do one more step to get to liters because I'm not quite in liters, so that means I need another equivalence. So this time, I'm in moles, I want to get to liters, and I want to be able to cross off moles. So now, mathematically, mole times liters divided by moles, since there's a mole upstairs in the numerator, mole downstairs in the denominator, they're eliminated mathematically, and I'm left with a unit of liter. Now, I've proved this mathematical sentence with units. Now it's time to put in the information so I can use my calculator. So here we go. 1 mole of a substance is how many grams? So because we need a gram number, what we go in the equivalence is we need to know the GFM of CO2. So over here we have 1 carbon, which contributes 12.0, plus there are 2 oxygens, and each one contributes 16.0. So the GFM of carbon dioxide is 44.0. So 1 mole of carbon dioxide has a mass of 44.0 grams. Now on to the next equivalence. 1 mole of any gas at STP, it occupies 22.4 liters. So now in my calculator, 86.3 divided by 44, because 44 is down in the denominator, so 86.3 divided by 44 times 22.4, because that is in the numerator. When you take a look at this, our starting mass has 3 sig figs, so our final volume can only have 3 sig figs. So when you look at your calculator, answer of 86.3 divided by 44 times 22.4, you have all those digits, and we keep 43.9 liters, and it's 43.9 liters of CO2 gas. So you go ahead and try the 2 you-dos on this page. Check your answers with your teacher.